Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we'll have a review of the distributive law. So the distributive law is how you expand brackets like this here. So remember, if no operation is written, it's times, so it's really this thing outside the brackets multiplied by what is inside the brackets. So we can draw a rectangle to represent this situation. So if we have this rectangle here on screen, its area must be length times by width, and the width of the rectangle is b plus c. But of course we can divide it into two smaller rectangles without changing its area. The area of this rectangle here is just a times b, and of the other one is a times c. So the area of this rectangle is a outside of b plus c, but it's also AB plus AC, and that's just explaining why the distributive law works. This is the distributive law. A outside of B plus C, what you do is distribute the A to the first thing in the brackets, and then distribute it to the second thing in the brackets, and there's a plus in the middle. A plus goes in the middle of your answer. So let's look at some examples. So if we have something like this, 2 outside of x plus 3, you distribute the 2 to the first thing in the brackets and to the second thing in the brackets. Sometimes people forget that. Please don't. It's not 2x plus 3, it's 2x plus 6. If we look at this second example here, we've now got a negative out the front, but we're not going to do things any differently. We just have to be careful regarding the signs. So minus 3, we distribute it to the first thing inside the brackets, and then we distribute it to the second thing. But minus 3 times minus 7 is positive 21, so I put a plus there. Sometimes the thing outside the brackets will be a pronumeral. So I've got something like a outside of 4a minus 5b, same thing. So a times 4a is 4a squared. Make sure you don't make this mistake. People mix up a squared and 2a. A times a is a squared. A plus a is 2a. We then distribute the a to the other term. So a times negative 5b just gives us negative 5ab. How easy is that? So now let's look at some examples where you have to expand brackets and then collect like terms. So let's say now we're going to have two brackets and we're going to collect like terms. So what we do is the first bracket and the second bracket separately. So doing the first bracket, 4 times x, and then 4 times positive 3. So this isn't a 7 outside of the brackets, it's a negative 7. So I go negative 7 times 2x, which is just negative 14x, and then negative 7 times negative 5 gives us positive 35. So remember, I can only add or subtract terms if they are like terms, which means if they have the same sequence of pronumerals. So this term here, terms are separated by plus and minus signs, and this term here, they both have an x, they are like terms. So 4x minus 14x gives me negative 10x, and then the other two terms are like terms because they have no pronumeral. 12 plus 35, and that is my final answer, minus 10x plus 47. So now let's look at an example where we just have a negative out the front of the brackets. Let's have something like 10 minus 2x minus 3. Okay, so normal order of operations, I want to do the brackets first. Now, when you have just a minus out the front, it's the same as having minus 1 out the front. All you do is change the sign of everything in the brackets. So we leave the 10 alone and not doing anything to it. So minus 2x, I change the sign of the 2x, and I change the sign of the negative 3. Now I've got two like terms, so I collect them, and then I'm done. So if there's just a negative sign with no number outside the brackets, treat it as negative 1 outside the brackets. So now let's have a quick look at going the other way, which is factorization. So what is on screen at the moment is the distributive law that we were using on the previous slide. Now what we were doing was we were starting off with things that look like this. that had a bracket and end up with something that doesn't have a bracket. So going that way, where we are getting rid of the bracket, is called expanding. So in all the previous examples we did, we expanded the brackets. We can also go the other way, start without brackets, end up with brackets, and that's called factorizing. So it's called factorizing because we're writing this expression as something times something. That's what factoring means. So how we factorize is we take the highest common factor outside the brackets, and then what goes here is the first term divided by the highest common factor, second term divided by the highest common factor, and it'll be a plus or minus in the middle. So that may not make too much sense at the moment. Let's look at some examples to help us. So let's look at 2x plus 14. So it's looking a bit like this one here, and I want to write it as something times something, i.e. factorize it. So the highest common factor of the two terms, well, this is the first term and this is the second, 2x and 14, the highest common factor is 2. So I write 2 outside the brackets. So what do I times by 2 to get this term here? That's just x. What do I times by 2 to get this term here is positive 7. So note, if I expand this using the distributive law, I get this. Expanding and factorizing undo each other in exactly the same way that multiplication and division undo each other. If you multiply something by 4, divide by 4, you're back where you started. Similarly here, if I start with an expression and expand it, and then factorize it, I'm back to where I started. Let's say I want to now factorize 8x minus 20. Same thing. So the highest common factor of this term and this term, highest common factor of 8 and 20 is 4. What do I times by 4 to get 8x? That's 2x. It's just 8x divided by 4. What do I times by 4 to get not 20, but negative 20? And that is negative 5. Once again, if I expand my answer here, I'll get back what I started. Now, the highest common factor will sometimes be a pronumeral as well as a letter. So if I have something like 6ab plus 15ac, I take out what's common. So I'll do the numbers and the letters separately. So the highest common factor of 6 and 15 is just 3. But that's not the highest common factor because both of them have an A. So any letter that's repeated is also part of the highest common factor. So here, the highest common factor is not 3, it's 3A. So what do I times by 3A to get 6AB? Well, that's just times by 2 to get 6, times by B to get the B. What do I times by 3A to get 15AC? I need to times by 5 to get to 15, and then C to get the C. So what is in the brackets here should have no common factors. Of course, 2 and 5 have no common factors. There are also no letters remaining. So therefore, I know I've done something right. Once again, if I were to expand this using the distributive law, I'd get back what I started. Alright, I hope you've enjoyed this video. This has been the luckiest maths teacher in the world. Have a great day.